Okay, so our today's experiment is we want to change the light falling onto the LDR and do the measurements using Arduino. So this is the simple thing we need to do. As I mentioned, if you don't want LCD, you can just connect a single pin to the Arduino at A0 and write some code to get this reading and watch it onto your serial monitor. So that is what we are going to do as per the title of the experiment. First, you go to the thinkerCAD that you already did. Now you have to create login, which you already did. Now, next step is from your thinkerCAD main menu, select circuits and click on create new circuit. Okay. So I will also type that uh, select circuit and create new circuit. Clear till this point? Now you all will end up at this page where nothing is there. There is something basic over here and it's a blank screen. Okay. Now next thing what you have to do is type ARDUI and you will see Arduino Uno R3 directly appearing here, which you can bring and place it somewhere in the center. Okay. So next step is select Arduino Uno R3 from components. Okay, I guess everybody is with me at this point. Now, as I mentioned you, we need to have a photo diode. So you can type LIGHT and you will get photoresistor, which is nothing but LDR, and you place it appropriately. So I have added a photoresistor. Again, I will add that step to the component. Now, next step we need to do is connect this photoresistor to analog pin A0 so that it gets properly connected. So this connection we did. Uh, so if you go to the circuit diagram, this particular connection is already done. Okay. Next thing I want is to ground the other terminal of the LDR. So I will go back and ground the other terminal of the LDR. So I did ground. So now there is a LDR connected between A0 and ground. Next thing is we need a resistor. So I will take a resistor and place it here somewhere, which is, and now you need a resistance connection between VCC and A0. Okay. So A0 and this point is common. So I will take a wire from VCC and connect it to a resistor. And then other end, I will take it and either I can connect it there only. So now our connection is complete and now we are ready to read the LDR readings through our Arduino. Next thing is we need to write a code for this to get the output. So you have to click on your so then our next step is I will also mention add photoresistor and resistor from components that we did. Uh, Connect as per circuit diagram that we did. And now next thing we want is write code in Arduino IDE. So in the code, first you go to this file and select the example basics and click on analog read serial. Okay. So let me just explain you this code. What this code is doing is, I have just deleted the comments. First thing this code is doing is serial begin 9600. Next is, so it will start sending the data via serial port onto the computer with a baud rate of 9600. Second is void loop int sensor value. So this is a new variable declared here, named sensor value, and whose value will be same as analog read A0. तो जो भी A0 पिन पे वैल्यू आएगी वो हम सेंसर वैल्यू में लोड करेंगे. Now you can imagine this is under a loop, so this thing will continuously happening. So whatever value is coming will get loaded into the sensor value. Then you print serial dot print, मतलब ये serial monitor जो है उस पे print कर दो. What you want to print is the sensor value and take some delay. Now it's just 1 millisecond and then you keep repeating. तो यहाँ पे क्या हो रहा है, सेंसर वैल्यू रीड कर रहा है, प्रिंट कर रहा है, रीड कर रहा है, प्रिंट कर रहा है, रीड कर रहा है, प्रिंट कर रहा है. Okay, so this is how the loop is, and that's all you need for coding. I will also show you how to do the same thing using block codes, but not right now. I am assuming you all know C programming. For the school students who don't even know C programming, they can still do this thing using block codes, which is like a Lego block that goes and fits into one another. But right now, I will just use this C program. And then I will come to your software here. Now you see something called as code over here. So click on that code. You will see all the block codes. Now you have to click on this blocks and select a text menu. Okay. It will ask you something, become editable. Click OK. And it will generate a original code for you that you have to replace with the current code which we wrote. Okay. So now our code is ready. Everything is ready. But our monitor output is gonna come on a serial monitor. So I just click on this serial monitor and your serial monitor is enabled. To have a better waveform look, you can click on this waveform also, so that simultaneously you will see the output in terms of waveform. And final step would be to run the simulation. I don't know what is the initial value of this resistor and what is the initial value of this photodiode. So we'll just check whether it works properly. And once you run, you should see your values coming. It's all 1023. So I guess the voltage has hit 5 volt. That means the initial value of resistor was much more than your 1K. And now you can click on this photoresistor and change the light. So you can see as I am changing the light falling on this LDR, my values are reducing from 1000. It has gone as low as 344. And again, if light increases, you can see the values are increasing, and same thing can be observed on a graph there. So this is your experiment, and I will stop recording. If you have any doubt, you can ask me now.
Sir, what was the unit of those numbers?